Hey class, so we've been seeing a lot of questions about ringbuffer.java, so we're going to talk a little bit about how that's actually implemented. I am using the super high-tech Google Present to get over this, but the simple idea will be expressed here. The first thing is when we first start out with ring buffer, we're actually going to want our ring buffer to look something like this. Completely empty. This is a ring buffer of capacity 8. It holds 8 cells. You can count them 1, 2, 3, 5, 6, 7, 8. And initially, both first and last are going to be 0. Now, when we in-queue into our ring buffer, we're adding a number. So if I were to in-queue the number 5, I'd insert 5 into this. And let's go ahead and make this look nice. Let's do some centering here. Here we go. By in-queuing, now my last space needs to move 1. So instead of being 0, it's now 1. You see, last is going to be the place where we always do our in-queue. It's the first empty cell after our last number. So if I were to in-queue 6, I put 6 at where last is, and then I increment the last counter, which moves it to the next cell over. And I can keep doing this. In-queue 7, last becomes 3. In-queue 11, last becomes 4. Fix that little error marker there. And this is the basic thing. In-queue 3, increment last becomes 5. In this case, I'm using arrows. Keep in mind, of course, that these are just numbers, but this is the 0th cell of the array. This is the 7th cell, size 8. So from here, now let's talk about dequeue. With dequeue, we want to actually just increment first. Now, in doing so, we increment first, then this later will allow us to delete values. You could set this value to 0, but we'll talk about later why that's not actually needed. So the point is now the start of our ring buffer is here at 6, and the end of it is here after 3. So let's do a couple more in-queues. Let's in-queue -4. Oops, having trouble. There we go. In-queuing -4, increment last again. In-queue 17, increment again. And now we face kind of a quandary, because if we in-queue again, such as in-queuing 14, now if we increment last, let me actually real quick correct, before we incremented last was 7. And if we in-queue 14 and we increment last, you're going to see that now last is 8, but there's a problem because 8 is out of bounds for this array. So how can we resolve this? Do we need to make the array larger? No, we keep the array the same size, same capacity. But what we're going to do is when last is equal to the length, we're just going to bring it all the way around, over, back to the first element, last equal to 0. And the reason for this is, again, this is a ring buffer. So rather than thinking of it starting at 0 and ending at 8, it starts at first and it ends at last. And like a clock, once you reach the maximum endpoint, once you reach over here, you simply loop around again. So at this point, if I were to in-queue, keep in mind that 5 was there from the last time. If I were to in-queue, let's say, 27, I in-queue 27, and I increment last, and now you'll see that last and first are equal. Now at this point, this ring buffer is full. If we were to try to call in-queue, there would actually be an exception thrown here, which is in the skeleton code we give you. That's fine. You don't have to fix that. The key is that this should never be, you should never call in-queue here with a ring buffer this large. Now let's talk about dequeuing. So if we dequeue first, again, the idea is this value, it's really no longer part of the ring buffer. We don't have to delete it, but we don't think of it as part of the ring buffer anymore. And first is now 2. And if we dequeue all of these values, we'll eventually end up with first being 14, or the last value at index 7. So first is 7, pointed to the value 14. And just for, let's just say we in-queue some values in the meantime, so we in-queue 8. Last becomes 2. We in-queue 13, so last becomes 3. Now when we dequeue again, when we remove 14, we increment first, and we run into the same problem we talked about before. First is 8, which is out of bounds. So how do we correct this? We simply say, okay, well, instead of first being 8, we're just going to set it back to 0. And now you'll see we're back to a point where the first element in the array is the 0 index. But the idea of the ring buffer is first is going to keep track of where our value starts. We do this instead of more complicated array manipulation because this turns out to be very fast and speed is going to be absolutely needed for this homework assignment in order for sound quality to be good. I hope this was helpful. Always come to office hours, post on Piazza if there's any more confusion. I will see everyone in class Monday. Have a great week.